Hi guys, good morning. This is Vasantha, Assistant Professor, Computer Science Department, Peri Institute of Technology, Mannivakam, Chennai. So today we are going to deal about operating system for the Regulation 2017, Computer Science Department. It's a paper for the second year students of fourth semester, right? So we go to the topic directly. We're going to discuss about domain name system today, right? So DNS, a domain name system. Assume I have 50 client machines and I'm going to combine everything under a single name which will be working even in the LAN without any internet connection, and for that I'll be fixing a particular machine with the domain name. It's called as DNS, right? So the DNS, it has three main components where it do the service and then it resolve library and dig command. Okay, actually this one is these components are from BIND, Berkeley Internet Name Daemon. Okay, so this is the it's a standard. The bind is a standard, and it has every version for Unix and Linux. Okay, so these three components are given by the bind, BIND, that is Berkeley Internet Naming Daemon. These are standard for every version of Unix and Linux. Okay, so they focus on the service, that is for it runs on the DNS. The service runs on your DNS mission by answering all your client requests. Okay, and the resolve library, this is what works in your mail browser and then your mail software and whatever service is run by the server in DNS. Okay, so this resolve library, it runs in your web browser and in your mail software and all applications where the DNS used through the server, and the dig command. Okay, this dig command is used for testing your DNS by providing some tools. Okay, whether my DNS is working or not, whether my domain is connected or not, those things will be checked using this dig command, right? So now, what does the DNS actually, what the DNS do? Okay, the DNS runs over in your UDP, user datagram protocol. It runs on your UDP and it's specified with RFC 1034. Remember this one, it is RFC 1034. Okay, and this DNS, it's in your application layer protocol. That's the top layer of your OSI model. So this DNS is there in your application layer protocol, and this one is hierarchical. Okay, you can't override anything. It will happen based on the hierarchical format. Okay, it purely runs with your hierarchical format and you can change it as you like. Okay, and it has some similar functions. Okay, it has some similar functions where the unique file system will have its own unique process, right? And in this you will have components for DNS. Every DNS should have its own domain name, domain server, name resolver, and a name cache. Okay, I'll just specify here. Kindly you can see it, the components. Okay, these are the components of your DNS. Okay, and the first one is your domain. You should have a domain. Okay, and you should have a domain name, and the domain name, you should have a name server, and then it should have a resolver. Okay, whatever problems you have, it should be solved. So it has its own name resolver, and then it has its own cache memory, which is specified as name cache. Okay, so these five are the components of a DNS, and these components are of bind. Okay, these are all of bind, BIND, that is Berkeley. Okay, that is Berkeley Internet Name Daemon, right? And these components are for your DNS, right? So these are things, and now we'll go to the next one, right? It has something like recursive resolutions, right? It's something called resolution. So we will go to it directly, and you can say this directly as resolution. Or to specify recursive, we can go for a resolution directly. Okay, so how it works was like, always you will have a request from a client machine. Okay, assume my 50 machines system number 1 to 10, they have some request. Okay, they have some request. So the client giving its request, okay, I need some data from the machine 10, or I need some data from machine number 20. So like that, it's asked for a request, the client asking for a request. Immediately the server, there are two types, authority and non-authority. Okay, means like I'll be having a password for handling my server, or like I'll be having some authorized person to work on my server. So if the person is having authority, he will check the authority and then he will go back to the database and it will respond. That's all the work ends. The client requests with some data to the server. The server, if it has authority, it will check with the authority. It goes to the database and it will respond. That's how it works. And if the server doesn't have authority, okay, it will go for, or it will transfer to another server. Check this one, okay. If the person having the authority will check with the database and it will respond. If the person is not having any authority, it takes the client request to another server. Okay, and this server, until it responds, it will wait. Okay, once it gives a response, it go back to the server and it will provide the information to the client. Okay, understood? So this is how it works. And then when your query gets resolved, it travels back where the request is being asked. Okay, now we'll see the entire concept with this diagram. I have my PC and I need data from this one, the students data of EDU. Okay, what I do was, my PC gives a request to my IT people. Okay, these IT people will have so many variations on so many things, like government, organization, industries, companies, and education and institutions. Okay, I requesting for information from education, from STES. Okay, I need a students database. So what I do was, it goes to the IT. In this IT, it goes to the EDU domain. It comes to the EDU, then it goes to the request over here. Okay, sorry, this is 3 and this is 4. I'm sorry. So this is 3 and this is my 4. Okay, so it goes there. It goes to the STES, and then once it provides the data what the client needs, it will set back to this one and it come back here, and it gives here and come back to the PC. This works as your server and also client at the request and response mode. Okay, that's how it works. This is your resolution process. I'll go for the next one, iterative resolution. Okay, there you had your mission, that is like your client asks for a request and goes to the server. But if it is as authority, it will work directly by itself, or else it will transfer to the next server, right? In this one, in this iterative solution, it have only a single resolution to be made and returned. At a single time, only one data will be transferred. Okay, or at a single time, one will work into many processes, right? It has a single restoration process. It has different name server. Okay, different name server needed for this one, because it will have multiple number of clients and servers attached to it at a time. So it need to have different name servers to work on it. Okay, now when it comes to the server, it will have different one. When the server has a name, you can get the answer directly. You can ask the server machine number. You need to go for returning with the IP address, right? So for the server, if the name is known, you'll get the answer directly from the client and the server. And when the server works on a no name client, it returns with the IP address. These two works with your name and no name, and this one happens with your secondary server. When a server fails, it will get connected to the secondary server. So this server will work as a server, and this will provide data for this. Okay. And then the next one is time to live. This determines a name binding. Okay, how long time will be taken for transferring the data. Okay, so this is how it takes. It will determine the guaranteed name binding during time interval. How long time it will take, and within how many times, or within how long time it will give the data. Okay, now we'll go to the example directly. So sorry for the diagram directly. A PC, it needs data from the student, and which is under EDU. Okay, what it do was, it will get, as I said earlier, it has different name server. it gives its request to all the machines it has, and all will give back the data what they have. So the machine which needs and which gets the data will get its data very easy. That's how it works. Okay, so this is your iterative resolution. And then the next one is reverse name resolution. Okay, reverse name resolution, it's an important task of your DNS. Okay, it's a very important task of your DNS, right? What it do was it translate the IP address back to the domain name. Whenever you ask for a request and response, it holds the IP address, it doesn't hold the name. So it translates the IP address to the domain name. That's what it do. And then it provides the hierarchy for translating. It will not, whatever systems ask for it, it will not give everything as by itself. It will take time and it will provide everything based on your hierarchy. Okay, and it has a pointer resource record. It has a PTR record which shows the current position of the DNS, where the DNS right now, for which server, which client has been connected, which client is asking for the request, which client got the response. So it holds the current position, and this PTR provides the exact resource of your DNS. It means it provides a position where it works. Okay, and then each host has a client protocol with itself, and it's called the name resolver. Okay, it is called as name resolver, and the name resolver, it creates resolution request for message format. Okay, for each and every message there will be some sort of format, so it creates the resolution request message format for each and every one. And the last one the name resolver do was it passes a request message to the DNS. Okay, for example, if a client need a record or a request, it passes the information from the client to the DNS using your TCP/IP protocol. Okay, that's how the reverse name resolution works. And then the last topic is your name server. Okay, it's a simple one. It divides everything into non-overlapping zones. Okay, it has its own authority record. See the diagram, very simple. It's very easier, right? Organizer, name server, edu name server, STS name server, and STS CS name server. When the organizer need a record, it transfers here 1 to 2, 3, 4, 5, 6, 7, 8. So based on the steps, it sends a query to the local name server. The UDP moves it to the server. And then it forwards a request to the name server. Okay, the name server where the record lies in. Okay, and then it goes to the base of the entire data source and it will come back. Okay, the point number 5 to 8, each request comes back to it. So whatever request is asked for from whatever it transfers from a query to a local server to the name server to the data server to the database, and it comes back again to the server. So this is how it works. So this is about the topic we deal with our DNS today, and hope you guys understood. Whatever doubts you have and whatever clarification you have, you are ready to give your you can give your feedback and questions here and learn well. Thank you.